Good morning, everyone. I'm going to start a new chapter that is inverse trigonometric functions. Why do we need this inverse trigonometric functions? So, why can't we use the same trigonometric functions we have used until now? This is because we cannot solve some problems with our regular trigonometric functions sine, cosine, and tangent. Why is that? Because I'll show you an example right now. I'll simply draw one triangle. Okay. This triangle will has a side L, M, and N. At the side L, there is an angle formed of we don't know that is we are supposed to find it, and LM is of the side 65 and MN is of the side 35. So we have to find the angle L. How are we going to do? Let's take our conventional method of finding angle L. That is related to angle L. We know the length of opposite and adjacent. This is the hypotenuse because this is the right angle triangle, which is not given here, so we don't know that. So we know the opposite and the adjacent. So we are going to use tan because that is the sine function. That is the trigonometric function which deals with opposite and adjacent without hypotenuse. So how do we find angle L here? We know this much. Okay, I am going to substitute 35 by 65. Then what? How are we going to find the angle L? This is where we get stuck. And what do we need? We need a new mathematical tool to solve these problems like this. Unfortunately, our old friends sine, tan, or cosine are not going to help us because they are not up to the mark. So this is where we take new trigonometric functions. They take what do our initial trigonometric functions sine, tangent, and cosine do? They take angles which is given in the question and give side ratios, isn't it? But we need functions that take side ratios and give us the angle. So this is why we need inverse trigonometric function. We already know about inverse operations, isn't it? It is not like inverse operations. So what do we do? What do we do in the inverse operations? Can you tell me? Addition and subtractions are the inverse operations. So what do we do there? Uh, we take uh, uh, we take an addition, for example, and if at all we have added two numbers, we get an answer. And if we want to come back to the original number, we should do subtraction. So addition and subtractions are inverse operations, isn't it? Same way, if we want to do multiplication, if we want to do multiplication, what we have is we have a number and we want to continue and we do some multiplication, we get an answer. Now we want to come back to our original number. So what we do is we divide so that we get our original number. So multiplication and division, they are inverse operators. Okay, now we have us angle, we need a side. Okay, that we can do using our tan or sine or cos. Now we have the side, we need an angle, we need an inverse operation, exactly inverse of what was happening earlier. So the idea is the same as in inverse trigonometric functions to do the opposite of regular trigonometric functions. For example, the sine inverse, this is called the sine inverse, that's the opposite of sine. Okay, let me take this e out. Uh, Next, if at all I am using and it is the inverse of cosine, then if I take a tan, then it is inverse of tan. This is how we do inverse operations. Okay, so why am I explaining all this? If you know that the trig ratio, if you know a trig ratio but you do not know the angle, you can use this corresponding trigonometric inverse functions to find the angle. This is as simple as that. So remember, whatever I have written here, these are some pointers which will not be into use, but I'm just saying it. This sine inverse which I have already written, this is not equal to 1 by sin x. Okay, this and this are not same because this is inverse operation and not the exponent operation. They are two different things. Then, for example, if you have seen x exponent of -1 is 1 by x, this is not that. So you cannot do this. And if at all sine inverse of x, for example, if it is sine x, so same thing, but we can use sine x. Inverse sine can also be expressed as arc sine, and inverse cos can also be expressed as arc cos, and inverse tangent can be expressed as arc tan. Of course, this will not be useful in our mathematics, but it is used mostly in the computer programming languages, but not here. But we cannot write inverse sine as like this of some angle. This is uh, we cannot write this as inverse sine as this. This is completely wrong. Just these are the notations which can be used, which is used in some computer languages. That's all. Otherwise, you have to write this or this. This means exactly the same.